Hello, class. My name is Professor Sharon Chandley. I received my bachelor's degree from Boston University in psychology and women's studies and my PhD in experimental psychopathology from Tufts University. And we are here today to talk about the brain, and specifically the lobes of the brain, because if you didn't know it, your brain has 4 distinct lobes. So the learning objectives for this lesson are first to locate the lobes of the brain and be able to identify one function of each and to understand one result of brain injury or illness in depth. And believe it or not, we're going to do all of this in less than 5 minutes. So we're going to start at the back of the brain. At the back of the brain are the occipital lobes involved in vision. And this might seem kind of startling because your eyes are here and that information about vision travels all the way to the back of the brain, but that's how it happens. And so in this part of the brain is your primary visual cortex, responsible for most of the conscious aspects of sight. And if you damage this region of the brain through injury, you will be functionally blind, even though your eyes are working perfectly fine and doing everything they should be doing. So that's the occipital lobe. Coming down underneath the brain are the temporal lobes. We have one on each side. A lot of auditory information is processed here in the temporal lobes, which kind of makes sense because it's near the ear. Also, many regions that involve understanding and producing spoken language and some emotional and motivational behaviors are in the temporal lobe. One interesting part of the temporal lobe is called the fusiform gyrus, and it's here underneath. So we're looking at the base of the brain here. The fusiform gyrus is a temporal lobe structure involved in facial recognition, being able to tell you're my sister, you're my teacher, and you're my friend, just by looking at somebody's face. In fact, if you damage this region of the brain, if you damage the fusiform gyrus, you might experience something called prosopagnosia, which is a disability where you can no longer recognize people's faces. You can often figure out who they are by context clues. The person standing in front of your class near the chalkboard is probably your teacher, for instance, but you have difficulty actually distinguishing people by their faces alone. Above the temporal lobes, but behind the front, we have the parietal lobes. And these are regions involved in attention and spatial location. So figuring out where things are in space and attending to them. And an interesting phenomenon that can happen if you have damage to the parietal lobes, especially the right parietal lobe, usually via stroke, you stop attending to the left side of space. It's not that you can't see information in the left side of space. If I direct your attention there or you move your head, you can see it, but you neglect it. You don't pay attention. And so folks with spatial neglect, for instance, if you give them models to draw here on this side, they will draw them like this. They will neglect or leave off the details on the left side. And then finally, the frontal lobes are involved in motor control, especially fine motor control. So moving your body and what we call executive functions. And executive functions are all those kinds of intellectual planning, delay of gratification functions we think separate us from a lot of the rest of the animal kingdom. There's a terrible form of dementia called frontotemporal dementia, or FTP, that attacks the frontal lobes. And there's a deterioration of the frontal lobes. People with this disease rapidly lose a lot of cognitive functions and their personalities are forever changed. So there we have it. Frontal, parietal, occipital, temporal. Hopefully you learned a little bit about the lobes of the brain and one form of illness or injury in depth. Thank you.